Probably cross the ocean, maybe out at sea. I just wanna know you're still with me. Somewhere on a jet plane.
This is about models involving the following equation. So y prime, so the first derivative equals k times y minus b. And at first you might be wondering, like, what is this? Where is this negative b coming from? Because before we had the y prime equals ky as far as like the exponential functions, but I'll go ahead and explain this real quick. So we have y of t, let's say, equals ce to the kt. And remember I said c stands for principal, so you could think of this as p naught. Okay, but they write it as c. So then now we're going to have this new thing called plus b. Okay, so let's see, what else do we have? So this is the same as y minus b equals ce to the kt, right? Mathematically this is correct, as you would just subtract the b over. But anyways, okay, so if we take the first derivative of the left one, then we're just going to get the c, so c, because that's just a constant in front, times chain rule, times the k, and then the b, the derivative of that is just 0, right? So then let's do the same thing for the right side. So our y minus b, if we take the derivative on both sides, we're just going to get ce to the kt times k, because of chain rule. So, as we can see here, both of these actually equal k times, and then k times something. So k, and we can rewrite this c times e to the kt, right? Because this is actually this thing, y minus b, right? That's what we started off with in the top right equation, okay? So we can sub in the y minus b for this part, for the c times e to the kt, okay? So this actually equals our y prime. Yeah, okay. And technically it also equals the y minus b prime as well, but we just care about the y prime, because this is the original equation that you're trying to prove. Okay? So, yeah. Alright, now applications of this, they emerge when, let's see, for example, there's Newton's law of cooling. Law of cooling, which says that, let's see, y prime equals negative k times y minus t naught. Okay, where k and t naught, they're both constants. So it kind of resembles the equation that we were using before. Okay. Yeah. Alright. Let's do it. Well, okay. There's an example in your book on this, and I would just be redoing the same example, so I don't want to waste your time with that. So I'll move on to the next thing that they cover, which is free fall with air resistance. So I'm going to go ahead and explain that. Free fall with air resistance. Okay, so for this one, our equation, and this is derived from physics, so if you're really into physics, good for you. And yeah, they have a proof in your book as well, but I'm not going to waste your time with that, so I'll just write down the equation and I'll explain what these all mean. Okay, so again, here, you can kind of compare it to the equation that I wrote down for Newton's law of cooling, in that we have something in front, some coefficient, right? So the k and the m, those are just constants. So this is kind of like your k in the other position. Okay, this is like your y, right? And this whole thing is like your negative b, right? So negative b part. Okay, so the way we could rewrite this, let me go on to another slide so I can have more room to write. So this is the, I guess, kind of like the standard equation for this, for the original function y. We're not working, it's related to y prime, but this is the original function. So y equals b plus ce to the minus kt. Okay, and from the last equation, from the free fall one, we said that k is like negative k over m. Yeah, negative k over m, kind of. And then, well, okay. So in this case, the negative was built in, so we can make this a positive since all of this is going to turn into negative once we plug it in. Okay, so then our y is like v. And then our b, we said was, well, we said negative b is mg over k. So then a plus b would be a minus that, right? So if we plug everything in, all of our variables, then we get that our original v equals, so b in this case is our negative mg over k plus, and then we have c still, and then e to the kt, negative kt. So then negative kt. Okay? Alright, so that's for the free fall. And now the last subtopic of 7.6 is called Annuity. So we're going back to the whole financial topic. We have, okay, so an annuity is something that earns interest at a rate R. So earns interest at rate R, and at the same time, money is withdrawn, so taken out, at regular intervals. Okay, so our equation for this, I'm just going to write it so that you can use it for your homework. So p prime of t, so the rate of, this is just the rate of change of how much you have in your account. So rate of change, okay, is R, interest rate. So this is how much your account is growing. The money in your account is growing at any given time. So that's interest rate of how much you have in there minus n. So this is how much money is withdrawn at each interval. Or, yeah, the rate of withdrawal, I suppose you could say. And this, if you factor out an r, then it turns into r times parenthesis p of t minus n over r, right? And you see how by factoring out the r, we got it into the form of the equations that we were using earlier. So this is like our k, right? This is like our y, and then this is like our b. Okay? So then we could write an original equation. So this p of t is kind of like our y, so same thing, equals b, and so we're going to have n over r, and then plus ce to the kt. So k in this case is our r, so it's like that. So this is our final equation.